Ave Coders. In this lesson, we're going to look at some exploratory data analysis techniques. And as expected, the dataset of our choice will be the Titanic dataset. And to obtain this dataset, I've gone to the kaggle.com website. This website is known as an absolute go-to place for the aspiring data scientists. It stores vast amount of datasets, it has a great community, and it has some good tutorials for beginners. And of course, it is the place where you can take part in data science competitions. Some of them are for fun and practice, but some of them even have some money prizes. So you can win actual money for solving the data science problem. So the data set we're going to be looking at in this and a few other lessons is called the Titanic. It is quite famous data set. In this dataset, you're basically given a list of passengers and some features such as the age of the passenger, the sex, the town of embarkment, the fare they paid for the ticket, the cabin number, and so on. And eventually, our task will be to predict, based on the given features, what are the chances that a passenger will survive or not. And of course, we know who survived and who did not survive, so we can actually compare our result with the actual figures. I'm not going to be leaving a direct link onto this dataset on Kaggle, so you'll actually need to go to kaggle.com yourself and download this dataset. Look at it as at a simple professional test, because a lot of times in data science, you'll need to mine your own data. And if you're not able to find a simple data set on a simple website, then I have bad news for you. But let me show you what we're looking for. So we have three CSV tables: train, test, and gender submission. You can download all three of them, but we are particularly interested in the train CSV for now. Once you have downloaded them, you can go to your Google Drive and upload them to your Google Drive for later use in the Google Collaboratory. If you don't have Google Collaboratory just yet, just click the right button of your mouse and then choose Connect More Apps. Here you can use the search to look for the Google Collaboratory. It is free to download and install, and it is generally a great tool, and it is widely used in data science practice, especially for the pet projects and training. So here it is. We just click install. Then Google will be asking for all sorts of permissions like it cares. And if you'll click I agree button the required amount of times, you'll get yourself Collaboratory installed. By the way, Kaggle.com is also owned by Google, and there is a similar notebook incorporated into the Kaggle's ecosystem, but my own personal humble experience using it was not positive. It was logging me out and dropping the collab session in the middle of my work, so other people said that they didn't have this experience, but here you go. I believe that Collaboratory by Google built in the Google Drive is much more reliable. But like I've said, this is my own personal experience. This is how Google Colab looks like, and it is not much different to the Kaggle editor, but I'm going to use the Google Colab for this lesson. So after showing you how to start your new Google Colab, I've switched to the one I've already prepped beforehand. I'll leave the link to this Colab in the description. So in the first cell, we are importing the OS module and Google Drive module so that we can work with the drive space on our Google Drive. As you can see, I have the dataset in the Titanic Dataset folder. Then we import the required libraries such as Pandas, NumPy, and Matplotlib to work with the data. If you're not familiar with these libraries, I have full lessons on all of them on this channel. And then we're using Pandas, and we are reading in this CSV dataset into the data frame. And if you didn't know, in Colab on the left-hand side, you have this icon of a folder. So if we press it, you'll see the directory or rather the whole tree of directories, where we can find our files. And this third cell from the top is just my utility cell. It is just to establish the full path to the dataset that later on I'm using for my read CSV method. So essentially, train.df is the data frame that encapsulates our main dataset, if you'd like, and head method gives us first 5 records of this dataset. So we use run all to run all the cells. This will connect our runtime and will load our dataset into the data frame, and we are pretty much ready to go. So in this lesson, we'll begin to perform what is called the exploratory data analysis. So basically, we want to perform some initial investigation of that data. We want to discover patterns, anomalies, test some hypotheses, check assumptions, see whether we have some duplicates or some features that are not particularly of big importance for our target feature. We also will plot our features to see whether we have some trends or correlations between them. And because our task is basically to predict whether a passenger survived or not, then we'll try to establish a feature or a combination of features that has a direct impact on the survival rate. And in this particular lesson, we're going to be concentrating on the so-called continuous features. So basically, those are the features that contain continuous numeric data. But let's study our data first. Maybe we can spot some features that does not have direct influence on whether a passenger will survive or not. For example, passenger ID does not really influence anything. This is just probably an auto ID given to each passenger, so we can get rid of it. And then the name. I think unless the passenger is called Aquaman, their name will not influence or boost their survival chances, so we can get rid of the name feature as well. Same is true about the ticket feature. The P-class column already contains the information about the ticket class. We can assume that maybe first-class passengers who are given priority boarding the lifeboats will see that correlation probably in the future. But the ticket column, the values in ticket column, does not have a direct influence on the survival rate. So in that cell below, I will declare a list called cat feat, and in here I will just list all these features we want to drop. So passenger ID will drop some other categorical features as well, because we want to look at the continuous, aka numeric features first. So in addition to passenger ID, name and ticket, we'll also drop sex, cabin and embarked, because they all are non-numeric features. We'll explore them, but in the other lesson. In this lesson, we are concentrating on the numeric features. So we're going to use the train.df.drop, and I'm passing cat feat as an argument. So we're going to drop these features, and we also need to specify that we don't want to drop rows, we want to drop columns, therefore access equals 1. And now there is a flag called in place. It is default value, it is false, so we need to switch it to true. This means that we want to modify our current data frame, not to create a modified copy of that data frame. And once we've done with all this, on the next line, I will use the head method again. So train.df.head, just to observe our new, same old but new data frame. And here, as you see, we drop the columns, and now it's pretty neat and clean numeric dataset. And since they're all numeric, there is a useful method which we can utilize to get a basic statistic about this dataset. The method is called describe. Basically, it will give us a high-level overview of our data, and possibly we can spot something interesting. And it's a good idea to look at your data from different angles. Straight away, we can spot here that count 891, and the age is only 714, meaning we have missing values. And later on, we'll see one of the ways how to treat missing values. Now let's focus on this survived feature for a second. So it is our target feature and it is binary. So 1 for someone who did survive and 0 for someone who did not. It has 891 records, so this is our total. And since it only contains zeros and ones, mean can tell us how many of them survived. And indeed, it is historically accurate that only 38% of passengers survived. Take a look at the P-class column. So the mean value is 1, and you can see that max is 3. Therefore, we have 3 classes of tickets. So 1 is the highest class and 3 is the lowest class. So this makes P-class what is called ordinal feature, meaning they only contain values of specific levels. So P-class feature has only got 3 levels of values, which represent the class of the ticket. And following the same logic, SIP, SP, and PARCH are ordinal features as well. So which features can strongly indicate whether someone will survive or not? For example, people that will most likely be struck by a lightning are those who decided to take a walk during the storm in a plain field and with an aerial on their head. So long story short, we can group our features around our target features to see whether we can spot some correlations. I'm using the group by method from Pandas. Once again, if you're not familiar with this library, I have a wonderful lesson on this channel. Go check it out. And we pass the survived column as an argument, and then we use mean. And now you can see our features being grouped around the survived feature. So 0 and 1 represent whether the person survived or not. And we can read these values in the following way. So the average age of those who did not survive was 30 and something, and the average age of those who did survive was 28 and something. However, some of the values are missing and we'll need to deal with them as well. But take a look at the fare. So the average price of a ticket for those who did not survive was half as much as the fare for those who did survive. And P-class numbers correlate with the fare. Passengers with lower class and cheapest tickets were less likely to survive, because even in the movie, if you remember, the first class passengers were given the priority to board the lifeboats. But remember that we have some values for age missing. The choice of the method to deal with the missing values in the age column will depend on our investigation of whether it is a systematic error or age is missing at random. So we can use the same trick here. I will just copy the previous code, train df group by, survived, mean, into the next cell, and all we need to do is to replace survived with the age. And inside the group by, we'll also chain isNull method to the age. So this method meant to return true or false depending on whether the age is missing in a certain row or not. And instead of survive 0 and 1, it will return age, false and true. And this is an important concept to get your head around. So false reflects whether the value is not missing, and true, it means that the value is missing. And if to look at the data from this perspective, then we can see that the people with the age missing were less likely to survive. They had lower fare and lower class of their ticket. But overall, nothing really indicates that missing age is a systematic error. It is most likely that age was missing at random. Now let's visualize our data even more. And I'm talking about plotting. Since this is not a lesson dedicated to the Seaborn and Matplotlib libraries, on my channel I've got a separate lesson dedicated to them. So back to plotting. In essence, we're trying to understand the correlation between, say, age and fare features and our target features, survive. So what we're going to do, we're going to plot the age and fare distribution in relation to whether passengers survived or not. The type of the plot I'll use for the first example is called displot from the Seaborn library. And then we'll plot the same distributions, but with my favorite plot called distplot. So this is a distribution for those who survived and those who didn't survive in terms of age and fare. And now I'm going to change displot to distplot, and this will allow me to plot two overlaying histograms. However, and this is kind of sad, distplot might get deprecated in coming versions. The thing is, age and fare are continuous features, and this is why we plot them this way. However, for ordinal features, we'll use a different plot. So the distribution of age between those who survived and did not survive is pretty much similar. The only visible difference is probably at the lowest end of the x-axis, indicating that a lot more passengers of age 0 to 8 survived, which is good. However, on a second plot, which represents fare, we can see a huge spike. This is to confirm the highest casualties among those who had the cheapest tickets. But a word of caution, so we're plotting only the averages, not the full distribution. So you may notice that anything further away from this spiky region has pretty much similar distribution. But we can see that fare can probably be a good indicator, helping us to predict whether a person will survive or not. Now let's plot the ordinal features. So we want to plot three different plots because we want to establish the possible correlation between the three ordinal features, P-class, CBSP, and Parch, and the target feature, which is survived. So I'll be using enumerate here to loop over the list of these features. So I will serve as an index. It will help us to basically create a new plot for each of these elements in the list. So we'll pass I to the plt.figure, and col will represent, well, column name, so p-class CBSP Parch, and we will be using the cat plot from Seaborn library. So down the x-axis we'll have the representation of the possible ordinal values. For p-class, for example, it will be 1, 2, 3 for classes. Down the y-axis we'll have the survived, and data, of course, we're going to pass the train TF. So the type or the kind of plot will define as point. There are more. You can check them out. And aspect basically represents the size or the scale of the plot. All right, let's run the code and see if we can spot anything else. So the first plot should illustrate something that we were already suspecting. The lower the class of your ticket is, the less likely you are to survive. The second plot illustrates that the more siblings, so brothers and sisters, the passenger had, the less likely they were to survive. The last plot illustrates the relationship between number of parents and children aboard the ship and their chances to survive. So the bigger your family was, the less likely you were to survive. And it looks like not only Parch and CBSP represent pretty much the same information, they also show a similar trend. So why don't we merge these two features into a single feature, which we can call family? So code-wise, the family feature will store the results of the summation of CBSP and Parch. It's great that a single feature can preserve the information that was previously stored in several features. So less features is great. So let's plot this new feature in relation to the survived feature using cat plot. We'll have family down the x-axis. The y-axis will be still represented by the survived feature, and everything else will remain the same. So data will still be train df, kind will be point, and aspect will be equal to 2. And once we run that, we should see a new plot where the previous trend is still persistent, which is the bigger your family is, the less likely you are to survive. So if we can combine two features into one while maintaining the same trend or information, it is always a good practice to do so. So in the future, our model will have less features to care of. So in the future, we might use just this family feature. And remember that we still have this missing age values that we need to take care of. We've already established that they are missing at random. And in order to check that age is the only column which has missing values, we can use traindf.isNull and then .sum method. This will show us all columns and how many non-null or null values are there. So age has got 177 null or missing values in it. And since we've established that they're missing randomly, we can use the simple and naive method to fill them in. There are a lot of discussions on what is the best way to fill the missing values. But for this example, we'll be calling pandas fill NA method, and then we'll fill the missing values with the mean of all values in that column. This way, we're making sure that we're not biasing our model towards any of the outcomes. And of course, we're making modifications in place. And I can copy this isNull sum construction and paste it onto the next line. It is generally not a great idea to perform in-place operations and then try to display the results in the same cell. And later I'll show you why. But here you can see that all missing values been filled. So let's have a look how our data frame after all these modifications looks like. Let's say just 10 first records. So check out the age column. We have 22, 38, 26, 35, 35, 29, 54. But then we'll see that 29 is not actually 29, it's 29.6 something something, which is probably a mean of all values in age. So this tells me that previously the value there was missing. And also recall that family actually represents SIB, SP, and PARCH combined. Here we have summed them up into the family column. Therefore, SIB, SP, and PARCH are pretty much redundant. Otherwise, having these features that are highly correlated can cause something that's called multicollinearity in our model. You can study what that is on your own, but meantime, I'm going to use the drop method to drop these two redundant features. So just to make sure I'm not going to do any spelling mistake, I will just copy and paste them from that bit where we were merging them into family. And once I'll get rid of all the unnecessary symbols, I'll specify that we will drop them by axis 1 and will perform the operation in place. And I also owe you an explanation why it is generally a good practice to perform the in-place operation on its own, in its own cell. So for example, in this case, if I'll run the cell to perform the in-place drop, and if later I'll decide, I want to display the result, and I'll call the head method on our traindf data frame, then unfortunately I will run into an error because our notebook has already performed this in-place drop. And if we'll try to call head on the same data frame, it will not skip the in-place drop. It will try to perform it again. But of course, CBSP and Parch are not there. And as you see, there's a key error, CBSP Parch not found in axis. So I'll copy it to the next cell. And here you see nice and clean numeric only data set. So this was exploratory data analysis, primarily on the continuous features. We managed to look at some data cleaning methods and how to treat missing values. And in the next lesson, we're going to be concentrating on the categorical features. But for now, please give this video Emperor's thumbs up, toll the bell, and subscribe. That was V, and I'll see you in the next lesson. Cheerio.